First of all, I want to introduce myself. My name is Drake Quigley. I'm an account manager for our additive team here in Illinois. With me, I have the pleasure of having Richard Cromwell. He is a application engineer for us on our additive side out of Auburn Hills, Michigan. And you can see the lovely printer behind him over what is that, your left shoulder, Richard? J55. So we're going to be talking today about PolyJet printing, focusing a little bit on industrial design and how the J35 Pro and the J55 Prime can kind of fit that designer space. So without further ado, Richard, I'd like to hand it over to you and you can talk about the fun stuff.
All right, thank you very much, Drake. Hello, friends. My name is Richard Cromwell. I am the additive manufacturing applications engineer for the Midwest here for GoEngineer, and I'm the AM lab manager in Auburn Hills. And today we're going to be talking about the new J35 Pro and the J55 Prime and how they can be used for 3D printing in industrial design. So let's just get started. So I think like a really good way to introduce the machines and their capabilities is in a way that design engineers might actually use the printers. So we're going to walk through just an iterative design workflow, general one, that features the technology. So just as a review for those that aren't familiar with this idea, there's lots of different ways of organizing iterative design workflows. And some people have organized them into several codified formal systems. But they all essentially share the same steps. The nomenclature might be different, but the idea is always still generally the same. And you have a planning phase. You actually come up with a design. You continue to develop the design. You test the product, and you deploy it. And then you review the data that you collect. And eventually you'll launch the product. Now, what happens in an iterative design process is that this portion, the design, develop, test, deploy, and review, continues to loop, and that's how you refine the product. So, another way of looking at this is if you have a certain amount of time that you're going to be developing a product and you're going to spend a month approximately, less than a month maybe, to define the product and then to create revisions and ideas to further develop that product before you come up with a concept design. And then we actually reach the detailed design phase, and that's where that iteration keeps cycling. And it's the longest time during the development process. And the idea is behind utilizing this technology in your workflow is that under normal circumstances, because of the time constraints, cost constraints of traditional manufacturing of prototypes, you may only have been able to get 5 iterations done during that detailed design period. But what we propose with our solution is that you'll get many, many more design iterations in that same period of time before ultimately coming to your final design that you would deliver to the customer. Another way of thinking about this is that as model complexity increases in your design workflow, so does the time and cost associated with procuring those models. The J55 and the J35 allow you to change the paradigm of that fidelity and cost relationship because you're able to iterate so much faster. And that includes, these are high quality models as we'll see. And that will ultimately get your better products to market faster and more profitable. So if we're walking through the process, I mean, just like in the old days, everybody starts with a hand sketch on a napkin, or in my case, on an iPad, and you'll develop a rough idea of what your product's going to be like. Now, instead of just having a paper and pencil drawing, we can now have a form prototype that's printed out of the low-cost material. It's here. Focus. There we go. And so this is just the shape. And this takes just like 45 minutes to an hour to print. And there's actually techniques that you can use to simulate the weight of a product. So it's not just the form, but it's the density, the weight. So you can actually feel it and make alterations to that shape before you make any further investments. And so you can basically get it nailed down. The next level of prototyping would be something like this, where it's like a sketch. It's just like the black and white lines, almost like a wire frame. It shows where we have an opening, maybe a surface, a roughened surface for opening this top portion. You can see some beveling around the edges. And then there's actually a port for the USB. Sketch mode is pretty neat, and it's actually a function of the build preparation software for this period. Really cool. The next level of prototyping would be something like a function test, where we can actually create the next level of prototype and make sure that the top cover actually opens and closes properly. How much of a protrusion do we need here? The USB connection. And this is basically right off the printer too. Look at that. And, all I did was remove the support material, and no other secondary post-processing was done. So another prototype that you could use in this workflow is taking the same design and then starting to incorporate clear materials to show the placement of electronics to make sure that everything's going to fit inside, and how long the wiring needs to be. And this is actually a neat concept of incorporating clear and opaque materials to create design. It's very popular in the medical device industry, where they'll print bones and then actually have the medical devices inserted into the bones as opaque, so you can actually see how they interface with the physiology. It's a really neat application that communicates volumes to people that don't really understand or see how the physiology and the technology interact. And so then the final level of prototyping is like the CMF prototyping, the color, material, and finish. And so this is right off the printer with just the material removed, no secondary post-processing. You can actually remove the little earbuds and see how they fit in there. And this is you can see the value of being able to hand these prototypes to decision makers over the benefits that you would get over just showing them a rendering, a software rendering. And to take it to a completely next level, you have the option of being able to print the entire package, all the packaging material, including the interior, the manual, and the internal. So these capabilities are powerful, but it's not just powerful because you can make cool models. It's a cost-effective solution when compared to traditional machining and modeling that's been done in the past. For example, we had this same design created by traditional CNC modeling, and it took $405 and 8 days. where if you printed this in-house on a J55, it would cost you $84 in material and take about 5 hours. So right there, you have a 97.4% time savings and an 80.1% cost savings. So the current prototyping problems that you'll see out there is the size of printers. I have several printers here. I have a Fortis 450, which is a large format FDM printer. I have an F170, which is a smaller format FDM printer. PolyJet machine, we have an SLA machine coming. And so to have all these different technologies for different utilizations is great. But the nice thing about the J55 and the J35 is that they're incredibly flexible in your prototyping workflow, and they allow you to do a lot of different things that you would need a whole room full of other printers to be able to do. The printer prices for multi-material printers are very expensive. And previously in the past, you'd look at like a J750, J50, and they're hundreds of thousands of dollars. A lot of the printers out there today aren't really made for office environments. Some of them, like my 450, can be a little bit noisy at times. And you have the problem of odors coming from the machine, from the catalyzing of the resins. Functional prototyping can be a problem. And this was something that I just experienced with a customer last week, where they were using a binder jet machine to create consumer electronics, and they looked pretty good, but the feel and the mechanical properties were not even close to what they needed. Design realism. This has been a problem for a long time with 3D printing, and not only for in general, but also in PolyJet realms as well. Previously, trying to achieve high quality reproductions and simulations of organic material like wood grain, in like stone or ivory, or certain elements like that. It was very hard for the resolution to come through and make those simulations look real. But here's the thing: is those problems have now been addressed, and we'll talk about that in a little bit. Reliability and stability. This is a big one when it comes to 3D printing. I talk to a lot of customers that already have like essentially consumer grade FDM machines, and they spend a lot more time tinkering and calibrating those machines than they really want to, and it just eats up a lot of time. And this is something that you have to consider when you're looking at the cost of these machines, like the Stratasys machines relative to consumer grade 3D printers, is these machines are self-calibrating, and we'll talk about that in the story. Ease of use and post-processing. A lot of people believe that some of the more advanced full-color multi-material printers are too complicated to operate, and the post-processing involved can be really cumbersome. And then when you're outsourcing your prototypes to a fabrication house, you might have long lead times and unfortunately an IP risk, because you're sending your proprietary data away to be created by somebody else. And so you're opening yourself up to having that IP stolen. So what are the value propositions that the Stratasys J55 Prime and the J35 Pro provide? Well, it's a very small, these are both small printers. This is an office printer, and we'll talk about the J35 shortly. It's a desktop PolyJet printer. These are low-cost PolyJet printer systems in comparison to the older, in the larger J series, J750, J50, J26. These are office-friendly machines. They're made to run in an office environment. They're quiet, and they operate relatively odor-free. Multi-material functional capabilities. This is big. Now, in addition, previously the J55 was only able to do opaque and transparent rigid materials, and now The J35 and the J55 have the ability to do multi-material engineering grade photopolymers like digital ABS, Elastico, which is an elastic material, and we can still do the rigid barrel materials as well. So these multi-material design capabilities allow for great design realism, especially considering you can use GrabCAD workflow as well as KeyShot, and there's other software pre-processing that you can do that we'll talk about. These machines are highly reliable, and we'll go into that. Ease of use via touchscreen, and by bringing your 3D printing and prototyping in-house, you're no longer outsourcing. You don't have to worry about the transportation costs and breakage of models in transport, and there's no risk for intellectual property. So that brings us to taking a deeper look at the J55 Prime and the J35 Pro as a prototyping solution. So this is the Stratasys J55 Prime right behind me. It is a full-color, multi-material, office-friendly 3D printer. It allows you to create without compromise. It is designed for maximum output with a small footprint and an affordable price point. It's rough, ready, right, and real, created to fill your design intent at any stage, from single to multicolor, functional and multi-shore materials. And it spins your ideas to life. So you can communicate your design and functional ideas quicker and iterate more often with the efficient Prime. We'll look at some key attributes. It's office friendly, best in class footprint to printing size ratio, silent operation, and it's odorless. Ease of use, minimal post-processing with a washable support material, and you can operate it remotely with GrabCAD Print. I'll show you that. Multi-material, as I've said, we now have, in addition to the full color, we have rigid, tough, flexible materials. And when it comes to accuracy, we're measuring layer thicknesses in microns. It's 18 microns approximately. The quality of the prints, it's super high, Pantone validated colors. And you have some really great transparent abilities and an outstanding surface finish right out of the machine. So the little brother is the new Stratasys J35 Pro. It's a multi-material desktop printer. So where this one is, it's about 5 feet tall. This guy is about the size of a mini fridge. That's one way. Where you could kind of say it's from here up. On this machine. So this is a very user-friendly plug and play, and you have plug and play consumable replacements. So the cartridges pop in and out for the waste and for the resins. You have a smart wiper replacement. Basically, the smart wiper replacement, the plug and play roller bath replacement. Those are wizards that you have to, those are maintenance wizards that you have to run periodically. They're very, very easy. And the machine basically walks you through its own maintenance. The ready to print mode is great. You can, once you remove the models, clean up the machine, close it up, you can put it into wait for print or wait for a part, and then you can basically just send a part to the printer and it will start printing. So you can, I've been known to initiate prints on the J55 from my kitchen table. There's a smart material replacement wizard. Replacing materials on these systems is, once you're going to switch from one material to another, it's relatively easy. The machine does most of the work. There is a touch screen on both of the J55 and the J35, and they have a great graphic user interface. So again, both of these machines are constant and stable in terms of performance. There's zero mechanical calibrations on the part of the operator. And you also, this is great too, and it's something that I really appreciate running this lab, is you get remote software upgrades. They say that it's monthly. I'd say it's a little bit more frequently than that. And there's always new stuff that's coming out, new capabilities that are coming out in the back-end software for these machines. It automatically logs, collects and sends your reports as to material usage and what you're printing. So key attributes are the machine is very office friendly. It's super small, relatively speaking to other PolyJet machines. And again, it's odor free. It's a low cost machine. This is the lowest cost J series technology that Stratasys has ever put forward. It's relatively easy to install. I installed one, the J55 actually by myself. Multi-material capabilities. Now, we'll talk about what the differences are between the J35 Pro and the J55 Prime in a bit, but both of them have the ability to create clear glass visualizations, and they both have the same high quality print resolution. And then again, it's easy to use. You have the touch screen, low maintainability, and high reliability. So now we're going to go even deeper into the inside of these machines and take a look at the technology that drives them. So the build platform, most people when you're out there and you're thinking about 3D printers, their mind goes back to the Cartesian axis CNC-like machine that has a glue gun that basically spits out filament and layers. This is nothing like that. This is a totally revolutionary, no pun intended, concept when it comes to 3D printing, where you're using a polar axis, a rotational axis. The parts are printed on a rotating platen. Now, how it does this is it has a static print head. Now, this is great because this has to do with reliability. The fewer moving parts that you have in a machine like this, the less it can go wrong. And so by taking motion out of the print head, it allows for consistent material jetting and results in outstanding print quality. It also makes it much quieter than the legacy J-series Cartesian systems. The rotating tray allows for shorter radial 3D printing paths for faster prints and better quality. If you look at this picture, you can see that there's tracks that are outlined on the build tray. And those tracks represent zones that if you put something closer to the interior of the platform, it's going to print considerably faster than something towards the outer edge. And if you put something in the middle, it's going to be in between the two. So placement of your object on the tray affects print time, and we'll show you that. See this area here, this little pizza pie slice is the transition zone. So as this head moves on one axis, it needs time to return back to its origin. And so it uses this space and time in the rotation of the platen to achieve that. Here is something that's unique to these systems in contrast to the legacy J-series systems. This uses a UV LED for curing the photopolymer. It's a highly efficient LED with an expanded lifetime, and it allows for optimal print viewing. So there's no window tint necessary. Also, this is interesting too. When you look at the materials that are for the J55, 35, and compare them to the materials that are available on some of the other J-series machines, there is an S at the end of the J55, 35 materials. So like it's like Vero Ultra White S. And that means that they have been formulated to cure specifically to this LED light. These machines have an intuitive embedded interface with a 7-inch touchscreen. These printers are standalone, fully functional printers on their own. You don't have to have a computer directly hooked up to this machine to run it like you've seen with some other systems in the past. There's no external client required. You have the 7-inch touchscreen and the user-friendly graphic user interface. And the end-to-end maintenance wizards. And I can't say this enough. They really work, and they work easily, and they work great. Everything from head replacement to running pattern tests to make sure that the correct amount of resin is being ejected during a print. All these things are handled easily through a series of wizards. So I keep mentioning that this system is odor-free, and the way that it does that is by using a office-friendly Pro Aero odor extraction system. And it is a multi-stage air purifier that runs the any type of vapors that are produced during the print process go through the tube into the Pro Aero, and any of the nauseous or it's actually like it's not that bad. It's kind of like a poison candy type smell that comes from these resins is eliminated, and that's pretty great. It will actually remind you too when it's time to change the filters in your Pro Aero system. So it's a phenomenal accessory. One of the questions that comes up a lot is how do you figure out what size models can you print on this circular platform? And I think an easy way to demonstrate this is look at some examples. So here are those the earbud cases, right? And we were able to fit 28 of them onto a tray, which is quite, that's good throughput. Or you could fit one of these large U-shaped brackets. This bracket is taking advantage of the unique shape of the rotating platform. This is a neat part because it shows how long you can make like a single object. I recently had a print where this came up, and you can print some sizable parts. I like this tray. You have 6 different parts, but they're all mixed as far as their material composition. So you can have 6 of those on there. Or on the outer perimeter, we have these planetary gear sets, and we're able to fit 22 of these little 1.5 inch by 1.5 inch cylinders on the tray. So let's look at the time. And I mentioned before that by having the models closer to the center of rotation on this platform, it's going to increase the speed. And so we have these 2 camera models here, and we were able to print them in 7 hours and 1 minute, both of them. And it gives you, this is a breakdown from the GrabCAD print software that shows your material usage and how much support material is used. Now, if we look at a different build for comparative analysis sake, and we load up the tray with 9 parts, it increases the build time to 20 hours and 2 minutes. So this shows the power of actually filling up the tray. It doesn't increase the print time. Like if we have 2 parts, and it's not like an FDM machine where you have 2 parts and it takes 7 hours, and then you got 2 more parts, and now it's basically going to take 14. We went from 2 at 7 to 9 at 20. And so the throughput on a full build tray is great because you get to start to take advantage of how the polar axis system really works and leverage that. So let's look at the materials that are available for these systems. The materials come in 1.1 kilo cartridges, and we'll look at the first level of materials, the Vivid Vero series, and this is your magenta, yellow, and cyan that you use for full color printing. These are not opaque materials, these are transparent. And so one of the neat things that you can do is mix this with something called Vero Clear, And you can print reflectors in a variety of different colors. And so you can have clear elements that have tint to them, and they look great. And so it allows for the outstanding simulation of translucent plastics. You have an extended color gamut, and this really does allow for an unmatched level of prototype realism. So the next materials are the Vero Ultra White and the Vero Ultra Black. I'm pretty excited about these materials. They really do set a new standard in full color 3D printing because they are 99% opaque, greater than 99% opaque. And this is important and because this has to do with color fidelity on a fundamental level when you're printing with these systems. If you look at, like, I'll show you a model that was paused mid-print, okay? So it's printing the interior of this solid portion with a mix of all the different resins that are in the machine, so it creates this black color. But if you see, before it goes to the outer shell, which is, in this case, is gold, there's like a little white shell on the interior that acts as the backdrop for the translucent colors produced by the Vero cyan, magenta, and yellow. So before, not too long ago, we were using something called Vero Pure White, and that was about 94% opaque. And so what you'll see is if I printed a model like this, which has a thin shell and it has color on one side, print on the other, that if you held it up to a light, you could see through the model and that color fidelity would not be so great. With the new formulation of the Vero Ultra White S, which has greater than 99% opacity, now we have far superior color fidelity. And this goes for pretty much across the board. You're going to get better color definition than you were ever able to before. And like I said, when it comes to printing things like organic wood patterns, these subtle gradients of brightness and contrast make a huge difference. This is actually the painting that was 3D scanned and I used for this slide. And the quality of these prints is amazing. You can actually see the individual brush strokes that came through in the scan. I wrote a rather long blog post about the Vero Ultra White and Vero Ultra Black and how important they are to high fidelity PolyJet printing. And you can go to GoEngineer's website and look at that. I'll post, let's see if I can post the link. So the next material that's super exciting is the Vero Ultra Clear S. This is a rigid material that can achieve outstanding transparency, and according to some is the clearest option in the 3D printing market today. It is very, very good. There is a product used in SLA called Water Clear that I think is just as good, but it does, that's a whole different ball of wax. This is a simple way to model clear material. It prints high clarity and fine detail models similar in appearance to PMMA and glass. And so check this out. I have this reflector that I printed out of Vero Clear. And I've actually been able to print lenses in Vero Clear that were able to reproduce a reflex. You can also do things like displacement. See my Jurassic Park bionic mosquito in there? So this allows for improved visualization of internal features, ideal for form and fit testing, just kind of like the model that we had with the electronics on the inside. Also, it's really great for showing the internal channels for fluid systems. You need, this is actually a emergency ventilator that I designed at the beginning of the pandemic. based on one that was created during the Vietnam War. You can also use it to mix and match. You can put logos, color logos on transparent materials. This is a little angle gauge. Or in Detroit, this is a big thing. We have the car logo medallions. By adding Vero Clear on top, it adds a sense of displacement to the model, depth. Graphic gray is a great material. It is for low price concept material, 50% of the cost of like Vero Ultralight. It's ideal for vast, low cost iterations in the beginning of the design process. Remember our shape model that we created? It comes in a gray color, great for examining the shape of product and making decisions. I really like to use gray for concept modeling, even in FDM, because you can see the contours well. This is, okay, so all these materials, the next three are new to the J55, J35 series of printers. This is Vero Contact Clear. It's a biocompatible material. It's good for skin and mucosal contact applications. Again, fluid dynamic and see-through applications, concept modeling of medical devices, and wearable and fashion applications. Previously, we used to have biocompatible materials printed on a different printer because the J55 and J35 didn't have that as an option. Now they do, and so this is, I'm excited for this material. It's something I'll make use of. This is another big one, digital ABS. So digital ABS is a combination of two different materials. It combines a high temperature resistance material and a high toughness material into one. And it is excellent for impact resistance and shock absorption. It has high thermal resistance, relatively speaking, to other PolyJet materials. It's available in an ivory color. Just one thing about this, one interesting application that people like to use for digital ABS is urethane casting. Another material I'm super excited about is the Elastico flexible material. It's a state-of-the-art rubber simulation material with exceptional tear resistance capabilities. This is the J55, J35 version of what the other J series machines, larger format J series machines, use Agilis. This is a cool material because you can see how they did over molding on this part. So you can add soft touch elements and over molding to your components, all with variable shore value. And if we have time, I'll jump into that. So here's the dimensional printing accuracy. The differences between Agilis and Elastico is Agilis, the shape that is printed is not as accurate in Agilis as it is in Elastico. You can see how this, the Agilis orb is kind of depressed looking, and the Elastico one looks nice and round. Same with the cubes. There's no part size limitation for the use of Elastico. Improved elongation of break, and improved tear resistance. The support material that these systems use is not a soluble support, but it can be washed away. That little part right here, that you just pull it off the printer. The printer will put support anywhere that it needs it along the sides of the part. It doesn't really need to put it on the top, and so if you don't, you can go into GraphCAD and say you don't want it to put it there, and you'll get a glossy finish. Most people will break away the material by hand and then use a power washing system. So let's talk about the specific differences between the two machines, J55 Prime and J35 Pro. And do they matter to you? So the J55 is for printing in full color. The new Ultra, the Vero Ultra White and Vero Ultra Black, they allowed this 160% of color gamut standard to be exceeded, and it increased the the color capacity of over the original J55, which just had like the barrel pure white, by 28%. So you can get some hyper realistic prints out of a J55. All right. The J35 Pro is a little bit more utilitarian, and this is for a good reason. One of the biggest things that happened over the year of me running this machine was that people would say, oh, I love it. However, I don't really need full color. And so the J35 Pro solved that and gives you just what you need, which is high contrast grayscale. Materials are easy to swap on this machine. The J55 Prime allows you to hot swap on all the material channels. So you have 5 materials. You can see here, material 1 through 5, and then this channel's for support. This cardboard box at the bottom is the waste collector. I actually made a video on YouTube about how to change the waste collector. Go check it out. The J35 Pro gives you 3 materials as opposed to 5, plus the support. But you can still hot swap the 1.1 kilo cartridges on 1 or 2 channels of either selected model and or support material based on the configuration. And you can cold swap the materials if they run out on all material channels. The machine will notify you via email, and there's a buzzer that goes off. I actually wrote a blog post for GoEngineer that details the 7 different material configurations of the J35 Pro. And even though there's only 3 materials that you're printing with, you can see how powerful that is. So in this particular setup example, we're using what they call full cycle 3 material plus support. You can print all of the different components of this lens assembly, including like the grip overmold with a Shore value of 45A. You have some simulated polypropylene, or the clear lens. So there's a lot that you can do with just these 3 material bags. And it goes even further than that. Like you can do the overmolding, the fit and form, function testing, shock absorption, high contrast labeling. The simulated fabric is pretty great, I must say. You can do everything from like this denim material, then there's like a carbon fiber weave that's pretty convincing. So lots of possibilities, see-through elements. So this is a really information-heavy slide, but I just put it up here because I wanted to show you specifically what the difference is. So the materials are the difference. The J55 Prime can do the CMKY full color printing, where you're limited to the engineering grade photopolymers in the J35 Pro. The print height on the J35 Pro is slightly shorter in the Z direction. Like it's basically an inch or less difference. The biggest differences are in the size and the weight of these machines. This bad boy is about 500 pounds, and the J35 Pro is only 200 pounds. The machines themselves, you know, this is more of the size of a filing cabinet or something like that, and then you have the J35, which, like I said, is the size of a small dormer and refrigerator. But here's something that I noticed on this information, though, that I found super interesting, because I've wanted a camera on my printer for quite some time. Apparently, the J35 Pro has a camera installed, so I'm excited about that. Although I don't know, if you watch it, you might get dizzy. The J55 Prime and the J35 Pro pre-processing workflows. We'll touch on this real quick. The file formats that these systems can read are STL, OBJ, 3MF, Vermal, and of course native CAD files. These are various pre-processing softwares that I use all the time. I do a lot of modeling in SolidWorks. I do vector painting in Nomad. I apply textures in Photoshop and Keyshot, and I also use Materialized Magic's a blender for mesh modeling, and Topology is a great application for topology optimization. It uses implicit modeling. It's a very powerful software. But the real hub of the software behind the J series and the J35, J55 specifically, is a GraphCAD print. This is the build processing software. It's proprietary to Stratasys machines. It's great for 3D print preparation. It can do both PolyJet and FDM. Allows you to control multiple printers. It's CAD agnostic. You can, whether you're using Siemens or SolidWorks, it doesn't care. You can schedule your prints. This is important to maximize your printer utilization. You get real-time notifications. I get emails from the printer when it's done printing, so I can know it's time to reinitialize the printer. It does all of your recording and reporting of job history, material usage, print times. It throws up error codes. You can avail this. Your printers are available to you via mobile monitoring. So there's an app for your phone, and it's available on both Apple and Android devices, and you can basically monitor your prints from anywhere in the world. And the security that you can trust, Stratasys works in a range of industries from defense to aerospace to medical, and so protecting your data is very, very important to us. And again, this isn't just for PolyJet, you also have the advanced FDM control. This is important to design engineers. You have the ability to use X-ray color profiles. And it's a great workflow working through GraphCAD. You have, like I said, your printer and job statuses, direct CAD import, and your material usage. And it can do so much more. I could do a whole webinar on just it. It's really good at fixing models as well, which is really terrific. It can heal meshes exceedingly. One thing that I didn't mention is there is an application that ties into all this called GraphCAD Shop, and it is a job management application. All of this software you can go and download for free from Stratasys and give it a try, see what you think. So what is involved in post-processing with these systems? I'll tell you right now, the most important thing that you're going to want to get is one of these water jet systems for support removal. It's essentially like a power washer in a box, and it allows you to quickly remove the support material from your models. It has other things that I would recommend you get if you get one of these systems. You want to have nitrile gloves around. Isopropyl alcohol in a spray bottle is great to clean the system. Water in a spray bottle to clean the tray and maybe your hands. Paper towel. I go through copious amounts of paper towel. A palette knife to help remove models from the tray, and a scraper to help get any residue off of the tray. The site requirements are relatively simple. You need a water supply that will help you with the support removal and cleaning off your models. You need a drain so you can dump your wastewater, and a 110 standard single phase electrical outlet. There is one other accessory that is brand new. It's called the Stratasys Pro Bleacher. Previously, when you were printing in clear materials, if you wanted to expose them to a UV post cure to help improve clarity, a lot of people would make these boxes and put reflective material on the inside and add UV lights and stuff. They would all try to do this. There's now a turnkey solution provided by Stratasys that uses a touchscreen, allows you to control the time and temperature. It's a safety interlock, so it turns off the lights when you open the door. It's a fast photo bleaching system that has the correct type of wavelength LEDs. And, it really works in improving the overall clarity and removing any yellow or any type of discoloring artifacts that used to be present more in in PolyJet models, but with the new Vero Ultra Clear S, I got to say that it's pretty good even now. forward version. And so actually, this is my final slide, which is going to bring my presentation about the J55 Prime and the J35 Pro to a close. I do want to just say a couple of things, though, before we go on about GoEngineer. This is our mission statement. GoEngineer provides design and manufacturing tools with expertise that enables customers to reduce the cost, risk, and time required to go live with new technologies and ultimately new product introductions. We are here for you to support your technology innovations. We have a number of offices spread out across the entire country, and there are more opening all the time. We offer classroom training for software, including SolidWorks. We're the largest SolidWorks reseller in North America. In addition to being I believe we're the largest Stratasys seller in the world. The online resources that we have available, whether it's through our website, our blog, the YouTube videos, we have a huge library of materials available for you to learn from. And then we also do SolidWorks certifications. We provide tech support for 3D printers, as well as training, and we have a service bureau. So we can print your parts if you want to try to validate materials or a system before making an investment. We can help you do that. And there's other services we provide as well: computation, CAD automation, rendering, hosting. And so please sign up and subscribe at all of our various social media channels, from YouTube. We have a great newsletter that goes out periodically, and you can register for SolidWorks training.